last time we have created our initial variables for our Cloud Spotter. Let us now program our Cloud Spotter. And I'm going to remove the update function because we don't need it. And the first thing that we are going to program is we are going to set the minimum and the maximum x. So here I'm going to create void set min and max x. And how we are going to do that? Well, I'm going to create here a new vector3 which I'm going to name bounce. And it's equal to camera main screen to world point. And this takes a new vector3, and at the moment I'm going to set 0, 0, 0 because I want to explain what this actually does. So we have this screen to world point. I have already mentioned the world position when I explained how can we resize our backgrounds. So this, what we see here in the scene, this is our world position. Even if I take the camera here in our game view, and if I position it here on the x-axis, here on the y-axis, this is still the world position in Unity. And let me just set it at 0, 0 again. This is still world position. So everything that we see here in our scene, this is Unity's world position. Now, here what we are doing, we are saying screen to world point. When we run the game, this is what we see. This is our game view. And now if I rerun it again, so this is what we see. And in my computer or on my computer, on your tablet or phone or anything else where you play the game, you have screen coordinates. So you have a screen when you see the game. This is from my monitor or on your display on your phone. So that what you see, those are screen coordinates. If you touch anywhere, so if I click here, these are screen coordinates because I'm touching on my screen. I'm not touching Unity's world space here. I'm touching on my screen. So these are our screen coordinates. And I'm going to use the screen coordinates and convert them into world coordinates. Because then we are simply going to determine the, minimum x and the maximum x. So taking our screen coordinates that we have here and converting them into Unity's world coordinates. So this is what we are doing here. And in order to do that, so for the x-axis to convert the screen coordinate, I'm going to use screen.width. And this is going to give me the x-axis for my world coordinates. And you can assume what I'm going to do for the y-axis. So I'm going to say screen.height. And this is going to give me the y position of our, world coordinates. We don't actually need this height. We only need the x-axis because we are simply going to strict the clouds here, so on the x-axis. But I have just added screen height and explained what it also does. So now I'm going to use the minimum x is now equal to negative, or first I'm going to use our maximum x is equal to our bounce dot x. So if I go back, this is that, bounce. So if I take the camera, this is our max x. So this one right here, this little cube that I've just clicked. But we are not going to add it, or this is not going to be our maximum bound. So I'm not going to use this one exactly, because if we take the cloud, let me take this one. And if I use this, so the last, let me just say here. So if I use this as the maximum bound, when we position the cloud, there is a slight chance that our cloud is going to be positioned like this. So we don't want that. Instead, I'm going to subtract 0.5, and this is going to be allowed. This is going to allow me to position our cloud potentially here. So simply I'm going to go back here and subtract from it. So I'm going to say minus 0.5 f. And I'm going to do the same thing for our min x. So our min x is equal to the negative bounce x. Because if I go back here, if this here is the positive side, so if this here is the maximum or the positive bound x, then the negative from it, is right here. So meaning the minimum x. And we are going to do the same thing. But now, since we have here the minimum, we need to add 0.5 to it to have the same effect that I've just explained for our maximum x. So here I'm simply going to say our min x is equal to negative bounds x plus 0.5f. And we are going to call this in the awake function. So here I'm simply going to say set min and max x. Next here I'm going to create a void, and this is going to be create clouds function. And this is going to be the function that's going to take our clouds and position them in our game. But before I use this function, we need to create here void shuffle. So shuffle, and this function is going to shuffle our clouds array. Or I can simply say here game object array and pass here, I don't know, just name it array to shuffle or something like that. This is going to be the function that's going to randomize the positions of our game objects. So here I'm going to say for int I is equal to 0, as long as I is less than array to shuffle dot length. So dot length increment I, and here what we are going to do, here I'm first going to create a game object which is going to be a temporary game object, and it's going to be equal to array to shuffle and the element that's at index I. Next, what I'm going to do is I'm going to create a random index which is going to be equal to a random range from I, which is right here, and our array to shuffle dot length. So each iteration of the array here, or of the for loop, this is going to create a random number between I and array to shuffle length. And I is going to increment each iteration. So now it's 0. Next time is going to be 1 because we are using I++, then 2, then 3, up to I less than array to shuffle dot length. And now I'm going to say our array to shuffle and the element that's at I index is now equal to array to shuffle and the element that's at the random index. And now our array and the element that's at the random index is equal to our temporary variable. And in order to explain this, I'm simply going to create these comments here and explain what's going on. So let's say I have created this game object and I named it temp, and now it's equal to array to shuffle and the element that's at I index. Let's imagine that this array is array of numbers, not of game objects. So this will be easier to explain. Let's say this array to shuffle holds the number 3. So it's equal to 3. Number 3 is at our array to shuffle and I index. So now we have set this 3 variable in this temporary variable. So meaning this temp variable, so let me just type this, right? So meaning our temp variable is now equal to 3. Now what we are going to do here is we have created this random index, and now I'm using this array to shuffle is equal to array to shuffle random. So the value, we know that our array to shuffle had the value of 3. So it had a value of 3. But now we have set this array to shuffle and the element that's at the random index, and let's say this element, let's say array to shuffle, so array to shuffle random is equal to 5. Now our array to shuffle is equal to 5 because we are setting it here. So array to shuffle and the random index is now equal to array to shuffle and I index. So now our array to shuffle is not holding the value 3 anymore. It's now holding the value 5. And this previous value of 3 is now lost forever. And that's why we saved it in our temp variable. Because if we did not save it here in our temporary variable, when we reinitialize or reassign this element here to this element, the previous value here is lost forever. Because now we need to take our random. So now we take our random, which at the moment, so moment has the value of 5. So e.g. random or array to shuffle random is now equal to 5. And because we set that value 5 to be now equal to our array to shuffle I, switching the position of it, so now this element is at this position, we need to set this element which was previously in this array or at this index, we need to set this position now here, switching that position. So now we simply say array to shuffle random is equal to temp in order simply to reposition these variables. So you can copy these comments in order to understand what's going on here. I'm going to delete them now, so you can pause the video for a second and you can simply copy this with, well, excuse me, I've stopped here for a second. So you can copy my explanation of what we are doing here in this shuffle function. So I'm going to delete it now. And the first thing that we're going to do in our create clouds, we are going to shuffle our array of clouds because we want to randomize the position of our clouds. So here I'm going to say shuffle passing our clouds because we set here to take an argument of game object, and our clouds is a game object or game object array of game objects. So we are going to shuffle that game object in order to randomize the position of our cloud. Now we are going to write a for loop here. So I'm going to say for int I is equal to 0, as long as I is less than our clouds.length, so not cloud spawner, clouds.length, I++. Here I'm going to create a float, and this is going to be position y is equal to 0, because I want to initially start positioning our clouds from here. So if I take our cloud 1, I'm going to position it from here. So for the y-axis, that is. The x-axis is going to be randomized. So for the y-axis, I'm going to position this variable from here. And that's why I'm setting this variable to be equal to temp. So, or excuse me, to be equal to 0. So now what I'm going to do is I'm going to create here a temporary variable vector3, which is going to be equal to clouds and the element that's at i.transform.position. So now I have the position of the cloud that's at element I. I'm going to say temp.y is equal to last position or position y. Also our last cloud position y is going to be equal to position y, because that way we are going to store the last position y of our cloud. But for our x variable, so here I'm going to say temp.x is equal to random.range between min x and max x. So max x like this. This is going to be our x-axis, and that way we are going to randomize it. Also here, I'm going to reassign this back to our cloud. So I'm going to say clouds, the element that's at I index.transform.position is now equal to our temporary variable. So we can test this out actually right now. So here I'm going to create the awake function. We are going to call our setMinMX. After that, we are going to call our create clouds function. And now what we are going to do is we are going to take our cloud. So I'm going to take our cloud 1 and position it here, our cloud 2, position it here, and our cloud 3 and put it here. Let me select all three of them, position them a little bit here. So let me take cloud 1 again, cloud 2, and cloud 3. And dark cloud, put him here. And again, so cloud 1, cloud 2, and our cloud 3, and lastly again our dark cloud. So in total we have 8 clouds. I'm going to select our cloud spawner and set the size here 8 because we have 8 clouds. And I'm going to drag each of these clouds in this array. So we have here our cloud 1. So let me select the cloud spawner. So cloud 1, cloud 2, and cloud 3, and our dark cloud. And again, cloud 1, cloud 2, cloud 3, and our dark cloud. And now if I run the game, we see where they are positioned. So all of them, they are positioned right here on this y-axis. And one thing that we also need to do, because we see they are all here in the same y-axis, we need to go here and we need to take our position y. So position y, we need to subtract from it the distance between our clouds. And this is that distance that I was talking about that I want our clouds to have between them. So now if we go back and if I rerun the game, we see now that all of our clouds, or we see the position of our clouds. If I remove the backgrounds, we are going to see them even more clearly. So here is one cloud, the second, the third, the fourth, the fifth, the sixth, seventh, and eighth cloud. And we see the distance between them. And we also see the randomization in the in the x-axis. Now, in order to control the x-axis a little bit, for that I'm going to use this control x variable, which I'm going to set here to be equal to 0. And this variable, we are going to use it here to determine the x position of our cloud. So here I'm going to check if our control x, so control x, is less than 0, or if it's equal to 0, excuse me. So if it's equal to 0, we are going to, well, use a certain number in order to randomize our temporary variable. So if our control x is equal to 0, I'm going to take our temporary x variable here and I'm going to use a random range between 0.0f and our max x. And here I'm going to set the control x, so control x to be equal to 1. Because in the next iteration here, I'm going to say else if control x is equal to 1, so if it's equal to 1, I'm going to use here our temporary variable, and I'm going to position it from 0.0x and our min x. So we are going to generate a random number between 0.0 and minimum x. And here we are generating a random number between 0.0 and maximum x. And now I'm going to set control x to be equal to 2. And I can simply copy this here. And I can say else if control x is equal to 2, I'm going to position our game object from 0.1 or 1.0 and max x. So max x. And I'm going to set control x to be equal to 3. And here I'm going to check if our control x is equal to 3. And I'm going to position our game object from negative 1.0 and our min x. And also here I'm going to set our control to be equal to 0 again, in order to have again check so that our control x next time will be equal to 0, and this is what we are going to use to position our game object. Then it's going to be equal to 1, and this is what we are going to use, so on and so forth. So each time we are positioning our game object using, for example, here between 0 and max x, setting it to be equal to 1. Next game object is going to be positioned, or the x-axis is going to be positioned between 0 and min x. And for the next is going to be positioned, so here we are setting 2. It's going to be positioned between 1.0 and max x. And lastly, between negative 1 and min x. What's the benefit from using this, you might ask? Well, in this way, we can control the position of these clouds, so we can create these zigzag positions. If I rerun the game now, we see that we have these zigzag positions for our cloud. So this cloud is here, then this one is here, then this one is here, then here, so on and so forth. We have these zigzag positions. If we were to use only random range between minimum and maximum x, there is a slight chance that this cloud would be positioned here, and then the next cloud position here, and then the next cloud position here, like this. So all of them will be right below each other. But this way we can create, or we can control their x position and create this zigzag position each time. So we have here this cloud, then we have here this cloud, then this cloud, so on and so forth, having, well, this zigzag position. This video is getting too long, so we are going to stop here, and in the next video we are going to continue to program our cloud spawner.